Okay. All right. Go ahead. All right,
All right.
Professor Roy.
Thank you very much. Suresh Roy, I think I'm pretty good at supplier chain management because I was responsible for quality, delivery, and cost of the product at our contract manufacturing. And of course, if you recognize me, I'm a mentor for Jharkhand Entrepreneur Course, and that is how I like to be called, besides all that I've been able to achieve in the past. Let me briefly tell you Silicon Valley, because that is where all my experience has been for the last 45 years. These were the companies in 1970, when the Silicon Valley just started to take off. In 1980, more of these companies came and joined us. By year 2000 and beyond, you can see many, many more companies came into the Silicon Valley. Here are the largest companies in the Silicon Valley, along with the employment that they give to people. HP accounts for about 188,000 people. Besides all those were the largest companies. There are at least 600 companies which are very well known in the Silicon Valley. Here are some of them. I'm not going to go through them. Software, there are many software companies. All of these are software that you see. These are all the networking companies. Networking is hopefully whatever you're seeing and hearing today is flowing through one of the networks of one of these companies. And most probably is going to be Cisco system, whose routers and switches made this possible, our webinar today. Electronics, again, we are talking about semiconductor here. These are all the semiconductor companies, and I'm sure you recognize each and every one of them. Again, more semiconductor companies. And of course, you also have some disk drive manufacturers, Seagate, but they're considered as a part of electronics because they produce their own chip, own IC. We also have a lot of renewable energy in the Silicon Valley, and everyone on the left side are the renewable energy. On the right side, of course, nothing goes without entertainment, and there are a lot of entertainment companies on the right side. This is what is Silicon Valley. It started in 1910. In 1920 is when there was a depression, and the companies were not hiring people. So that is when Stanford went ahead and said, okay, I will open my campus to all the industries who want to set up their industry within my campus. That is where the HP and other companies started. They all started from the campus. Then you started having integrated circuit. These are all the ICs that were developed, and then followed by personal computers, then internet, then social media. And now everyone is talking about AI. Entrepreneurship is the heartbeat of Silicon Valley. I basically say that because Silicon Valley is about 1,854 square miles. In comparison, Delhi is about 573. And if you consider the whole of NCR, that is equivalent to our Silicon Valley. Silicon Valley is fortunate to have closeness to the universities, two of the best universities. Stanford, I think that has been ranked as number 5 university, and Berkeley, which has ranked number 2 universities in the world. So these are the two largest, and of course we have many, many others. For example, San Jose State University, which is right in the heart of Silicon Valley, where both professionals, they go for a higher education, and the professors, they come from the industry. So this is where the best of the two meet together, is in San Jose State University. Then you also have Santa Clara University. So you can see so many companies have their employees coming from these universities. And of course, the availability of qualified people and the laws that makes setting up for companies in Silicon very easy. Today, you can walk into the office, fill up a form, and you can start a business right away. That is how much it takes. As long as just to fill up the form, that is the time it takes to start up a company in the Silicon Valley. And that's what it should be. Everywhere it should be that way. Make it so simple that people can start their own company at any time, because once you establish your company, the chances are company is going to make money and you pay taxes, and that is what the advantage is. Going back to entrepreneur, this is what we have been talking about. The person who's willing and able to convert a new idea or invention. All of these people have some innovative ideas. They create a new product and business model for long-term economic growth. And that is why our professor always says that whenever you start a startup, you'll be employing a lot of people. And when that startup really grows into big business like Apple, you'll be engaging almost 180,000 people into this business.
Professor Roy,
Yes.
I would like you to go to your introduction slide and just show I saw that your startup, which you have worked on. Just go briefly on that. I like you
I
to do
really
that,
didn't
please.
want to do that, but since you're telling me, okay, I will go back there.
Yeah.
So all of this company that you see on the top, CMW was a company which we made EV cars. Solarletics is a company that I was associated that was for solar panels. And the whole idea was, because the old panels produce only 250 watts, what can we do to enhance their capability to produce more? And this was a company, Solarletics was the company that started to add 15 to 20% more output from the current solar panels. Edgeland and Keysight are two companies. I will not call them a startup company, but they are not into high volume type of production. They make very specific equipment for the specific industry. For example, Keysight would make all the test and measuring equipment for the electronic companies. For example, if Cisco says they're producing a product that is 10 gigahertz or 15 gigahertz, how do you really measure that? And how do you verify that it's 15 gigahertz and they're able to produce it and capture it? Keysight is a company that makes all the test and measurement equipment for all these companies. CradleTech is again a startup company which was into, I would say, most of your cameras and recording devices. Cisco System, when I joined, it was almost in a startup mode. That was in 1997, in which at that time there were less than 1,000 employees. Because today they are close to about 85,000 employees. Adaptec, again, almost like a startup. Quantum Corporation, like a startup. Comport was a startup company. OMEC was a startup company. And Quadrex was a startup company. Membrex was a large corporation, of course. So you can see my association with the startup companies of multiple different industries, right from car manufacturing to solar to disk drives to to networking to adapters that would Adaptec would tie up your computer for hard disk and other devices on your computer. Quantum was again a hard disk drive. So all of this, I've multiple experiences in multiple fields, and as I told you that my expertise is supply chain management. I set up at Samsung their first disk drive manufacturing. and got a lot of award from different. But the best award that I got was from my institute, awarded as the best service person for my MNIT, for providing my services to to my institute. And I hope someday I will do that same thing for Jharkhand University. I hope, Professor, that covers up all the. I didn't want to go into that because this is all
No,
past.
I'm glad because
Yeah,
we all need to know that so that so that we can ask you the questions relating to that when students can ask the question, faculty members can ask that question. Okay, and they know now, where to go to for because now these companies are most of the people, most of the professors, they're aware of these companies, so at least they can now relate it. Okay, go ahead, please. Thank you.
great. Thank you for that. And now, whenever I talk about my experience, from where I'm talking about. So working with all these industries. Silicon Valley is, again, you saw how many companies are in the Silicon Valley. And if there are companies, there's going to be a very severe competition. And most of the companies really come out to solve a real problem or give value to the people. That is what we are talking about. Entrepreneurship is to go and talk to your customers to make sure you understand that problem. Because once you understand the problem, only then you can come up with a real solution to the problem. In industry, every problem or a gap is an opportunity. Just like as students, when they go and talk to the farmers, there's a gap there. And those are the gaps which are opportunity, which students can avail as of today, or maybe once they gain more experience, more confidence, once they become more expert and expertise, that is, they will be very, very valuable to no matter farmers or any industry they so choose to start a new company. BMC, I really don't want to go into this, but this is the slide that is the most important. And that is why we are giving and focusing on this, because without really going into each and every block, you will not understand what it takes to start up a business. Because business has to be profitable in the end. And if you go through all of this, you will have an equation which says if we are going to be profitable or not. New product introduction, that is how we call it in the Silicon Valley, NPI. In India, we might call it new product launch or by different names. The whole idea behind all this is you have an idea, then you set up a team and then you start screening which is the best idea that you should really work with. And that is the reason we have formed a team of 10, because each one of the students in that team will have their own idea. And then all 10 get together and says, let's just screen this and give it a top priority on one item that we want to work on. So exactly this, this is how it's set up. Then you start talking to the customers and concept development and testing. How will you test the product? How will you do marketing to this? How will you do business analysis? That is your cost of the product. How will you do product development right from the lab to mass scale production? How are you going to do the marketing for that? And once all of that is done, then you go into commercialization mode. You can see here is a person, he's thinking, all the gears are working inside his head. And they have to work in such a way that in the end, you're ready to launch a product. But to do all of this, you really require your experience, expertise, and knowledge. Without this, you'll not be able to do much. At the same time, you need to form a team that has the same goal as your goal to make sure that everyone is responsible and accountable. So again, NPI team, it delivers a quality product at a predetermined cost. That's the difference between an established company. What professor always says, that in established company the process is already set up, and we have to be very precise when we work on a cost of the product, because from our experience we would know exactly what's going to cost us. Most of these companies, I'm taking this opportunity from my experience and taking Cisco system as as a mark on which I'm going to give this presentation. So this is applicable to any small startup companies when they become big, because this is the process that they need to establish at that time. Most of the product development idea really comes from the customer. We have our customer engineers who go and talk to the customers and say, what is your requirement? What is the product and what features it should have? That is where they pick up all of this, talk to different customers, and then they write a document, product requirement document, PRD, because PRD contains everything that the customer is asking for. Then PRD is given to design department, the design and development department, and we call that as engineering department, which also generates another document, which is technical requirement document, in which they exactly say what we are going to deliver, what should be the specification of that, what should be the lower and upper limit on which it should work. So again, exactly specified what it will deliver, how it should be tested, and what are the problems that potentially can come up. And once that is done, then it starts the chain of development at our design engineer. And then it really comes around for manufacturing to give their input to the design engineer at that time for two different purposes. Anyway, I'll come to that later on. But again, entrepreneur objective is in creating a new product or a business model. And these are the three factors. It has to be repeatable. Repeatable means it should be able to meet the original technical specifications. Until and unless the product does not meet their own technical specification, it's not ready for production. So there is a phase at which we do our test and manufacturing to make sure that it is repeatable. And then once it's repeatable, then it's scalable. Then we can go back and start producing in larger volumes, because now most of the customers are expecting this product. And once that happens, then it becomes profitable for the company. So my case study here is electronic product that involves both software and hardware development. These are very complicated boards, printed circuit board assembly, on which there could be anywhere between 1,500 to 3,000 components and up to 50,000 solder joints. Remember, 50,000 solder joints, and each solder joint must be perfectly done. Otherwise, it would lead to product failure in our manufacturing first. And in long term, it could also develop a failure once it reaches our customer. What are the resources that are required? Again, all of this can be in different format. You can call it any way, but the bottom line is you require money, you require manpower. These are the people who are going to produce this product. You require machines, because these machines should be able to test the product to our specifications. And then material, which is bill of material. We have to make sure that every product that is used onto this electronic should be pre-qualified. So every item has to be qualified, and then it has to be known the source from where we are going to get it. So all those sources are pre-qualified, and we cannot cross this. If they say this material is qualified by Intel, we have to make sure we have to buy from Intel every time. Method, what are the processes to transform everything into a product? Again, these are all the steps. Every product must be, people must be trained and well documented. A good documentation will make sure that the product is made as per specifications. There's no one can come in and say, can you change this? Can you change this or this? No, it will be only changed when there is a process that is put into place. Either it's a deviation or, or changes authorized by engineers. Everyone has to sign into that to make sure that, yes, that's the right change that is taking place. I really don't want to go into this section. Money, without money, nothing moves. You may not require money to start a company, but once you start making a protos, at that time, money becomes a key thing. Yeah, if you recall, I said I worked for CMW and we were making an EV car. We made one EV car, and then it required more money to do the toolings for the car. That is where we ran out of money because of the severe competition in EV car. People said, you might be good, but you really don't have a product as yet because we don't have money to go for the tooling. And that's some of the problem which most of the smaller companies they get into, financial issues. Manpower. Manpower are marketing people, engineering, technical services, manufacturing operations. And if I tell you, if there are students, I will tell you exactly that engineers, this is the place where you will be employed. For example, in marketing also, in customer service engineering also, engineers are required. Engineers are required in hardware design and software design, mechanical engineers, PCB layout and drafting, project managers. These are all engineers. These are the opportunities that every student has once they join a company that they will be asked to perform. Technical services such as the safety, compliance, and regulatory qualification. By regulatory means, it has to be, for example, UL qualified or CSA qualified, or even India have their own qualification sticker that, it must meet most of those requirements set for India, Germany, Europe, and even China has their own specifications. So we have to make sure that these products are able to meet the local requirement of the local, not local, of the countries in which the product will be sold. So that is the regulatory qualification I'm talking about. Then you have ISO 9000. ISO 9000 makes sure that the product is being built as per specifications. ISO 1400 is environment protection. So most of us have to be very, very careful to make sure that our product remains within the limits of environment control. Part of my responsibility when I went to China was also to make sure that the people who are employed by these companies, subcontract companies, should be able to pay a decent income for their employees. So this is also part of the audit that when we went in China, we did that audit. We went and saw where these people are living, and we talked to them with the living condition and asking them, are you satisfied with what you're doing? Because a happy worker means good quality work that can come out. And it was our responsibility, our social responsibility, to make sure that every employee is treated properly and has enough resources to manage his house. Customer service, you require program manager, IT support. We all know about IT support, and IT is a big thing in any electronic manufacturing, because customer has to go to your website and place an order, and out comes a a date at which it would specify you will get the product on this particular day, because it will do all the calculation that is required, all the lead time that is required, both from the point of view of material and point of view of manufacturing the product. You also have document control, as I said, which is very important. You have component engineer. Each one of these engineer is responsible for a component, and they also have the responsibility to keep on investigating what are the new products that are being released. For example, if you see what is happening in Las Vegas today, there are so many new products that are being released. That is, of course, not an electronic show, component related, but this is a show in which you have a full product that has been shown. There are close to about 2,000 companies showing their latest product right now in Las Vegas. If you get a chance, please go to one of the videos on YouTube and see what new is coming up. Again, there's a planning department, there are buyers, there's a reliability department, there is a packaging department, there's a counterfeit department, and of course the manufacturing at our contract manufacturer. Each of this department requires engineers. So this is where there's a lot of opportunity for an engineer to grow in a company. Now, it's not necessary that electrical engineer is going to do only electrical, or myself being a mechanical engineer, I have to do mechanical work. It is understood that once you have an engineering degree, you are sort of an engineer which can take up any role within the company. I myself became not electrical, but electromechanical engineer. I have never done mechanical after I graduated from my institute. That is where all the students need to understand that whatever they are learning, not only in their own department, but picking up a little bit of electrical knowledge, a little bit of software knowledge, a little bit of industrial engineering, a little bit of programming is definitely going to place them on a very advantageous position, because that's what is expected in most of this industry. When we're talking about these companies, most of the products are so complex because they are so advanced that you don't have a tester to test the product. What good is making a product which you cannot test? So these companies, when all the requirement from the customer comes in, they will go ahead and first build a tester to test the product. So in order to make a product, first of all, you have to make a tester and then make a product to test. And later on, many times it happens that the tester itself becomes a product for some companies. So that does not go as a waste. Input. This is the most valuable at that stage, is during the design stages, if we can give our input both to the material, layout of the components, and include field failure reports. And why I'm saying all this is it's very possible that design engineers do not know what are the material that are failing both as a part of the process and also in the long term. That is when it reaches a customer. And, and the field failure report, it, you have to go back and evaluate and come up with the root cause why it failed in the field. And if it is because of a component, then those components have to be always report to the design engineers to avoid using those components. We go to our component engineer and say, can you put an extra mark on this not to be used? If it can be avoided, please avoid using this because this causes a failure in manufacturing during the production stages or long-term failures as the field failure report. So this, all of a sudden, when this information goes to design engineers, we find that the quality of a product able to sustain for a longer time in the field is become a reality. And also, we are able to produce a product at a much higher yields. DFM, design for manufacturability, this is to make sure that whatever problem we have to manufacture a problem has to be put in as a part of the design consideration. And once that is done, we will be able to produce that product more reliability and with less failures. DFT is designed for testing. Again, we want to test hopefully every solder joint onto the board before it goes for test. But obviously, until unless you might have heard about ICT, in circuit tester. ICT has few locations in which it sends out a signal and it receives a signal. And if it is as per our specification, then we say, yes, it is good. But what happens in between could also cause a problem. So if we design for testing means if we put more test points onto the board, the chances are we'll be able to catch a problem at much earlier stages. Remember one thing, whenever there's an issue, there's a problem, it goes through rework. And sooner we can catch the problem, it's easy to rework and takes less time and less money. The longer into the process that goes on, for example, if there's a failure at the end of the test, then not only you have to rework, but it has to go back through all the tests all over again. And shop rate, remember, the shop rate is about $85 to $90 per hour. That means if a product takes 1 hour to be fixed, there's already $90 we have added to the cost. This is the direct cost. And then on top of that, there are indirect costs also that are associated. For example, when we do bill of material, that does not count all the marketing effort that went into or the design effort that went into or other expenses. This is directly labor expense that we give to our design engineers. And then they multiply that by 1.5 because that is the cost of the product. So field failure, again, very, very important. Every failure in the field must be analyzed for its root cause failure. Only then will we be able to improve the product. DFM I talked about, DFT, designed for testing, and DFA is designed for assembly. You want to make sure that number one, you have the minimum amount of hardware and screws to be mounted. And then everything should come from the top, one end, so that it becomes easy to assemble. We don't have to turn it upside down and screws from the left and right. If everything really comes from top, we'll be able to do it right. And then design for recycle, because this is becoming more and more important. Next is machines, test and measurement, because it's through the machines only that we'll be able to make sure that we are making a product that meets all the engineering specifications. For this, we might require a lot of software, a lot of design testing that goes on. At the same time, there's a lot of incoming inspection done on every component. Sometimes, if there is a failure, then the component is inspected, 100% inspection at receiving end. And then, of course, the feedback goes back to the manufacturer as to the defects that we are seeing. And there are defect reduction team that is responsible to make sure that these defects do not repeat. And then we have in-process testing, solder paste volume. If you're in electronics, all the joints are made through solder paste. And any difference in the volume will cause either insufficient soldering or shorts between the leads. Now, we're talking about close to about, 3 microns difference between the traces. The traces are very small. And if not done right, you will lead into shorts. That is where we have AOI. Again, these are the optical testing that there are cameras, high definition cameras that look at the board and they're able to see the defects onto the board. We also have X-ray machines. These are the machines because when we are talking about some of the leads which are underneath the components, for example, for BGA, CGA, and very high density component, those AOI machine will be not able to see because all that they see is what they see from the top. But X-ray machine will capture that and will tell us whether there's a short or an open underneath the component or even within the component if there's anything that is defective. ICT, I talked about ICT in circuit tester that is required for all the product. Once they are assembled, the first test is ICT. And then they go through some of the pre-test and the final test. The point here is, if the product is failing at the final test, it has to go back all the way. Final test is also very sequence of tests that takes place. As a manufacturing engineer, it becomes our responsibility. If the product is failing at the 6th test of the final test, and there are excessive failure there, then we try to go back to our test engineer and say, can this test 6 be included as a part of the pre-test so that we are able to identify that failure much before the final test takes place? That is a lot of input, a lot of teamwork working together to make sure that every problem is identified and corrective action takes place. Some of you who are into electronics or electrical engineers or even design engineers will know one of these lines. This is an SMT line, surface mount technology. So it starts with a loader on which a plain fab printed circuit board is mounted. Then this is all automatic. All that the operator does is load that loader, with all the boards. Loader will go ahead and print the serial number. That is where the sequence starts. So if we know how many boards have gone through the loader, we know how many boards are being produced on that particular line. So that is why serial number is very important, not only for the traceability, but also from the cost point of view. Because when we give our product to a contract manufacturing, for example, and they tell us that because they are going to tell each one of this machine working in series, not in parallel. So they'll say, okay, this time taken and added, and they'll say, okay, we are able to produce only 200 boards per shift. But when we go to the loader and say, by the way, you are able to generate 300 serial numbers there, How do you tell us that only 200 is your limitation? That is where we do a lot of analysis and working with our contract manufacturing, because we know exactly the time that takes at every station, because there's a barcode reader. Every time it enters one of those stations, it reads the time in and time out. There's an absolute timestamp on every process that is there. So as a part of the manufacturing engineer, we know what it takes in terms of time to produce this product. So it goes through stencil. Stencil is printing solder paste onto the board. And then it goes to inspection. That is to make sure, because there's a stencil, and once the stencil is lifted up, there could be chance that some of the solder paste also lifts with the stencil, and it's going to have low volume solder paste at some location. But our solder paste inspection is going to point that out, and it's going to generate a report. We are not going to stop the process, but at the end, after it comes out as an assembly, that report will be seen by the technician who will verify whether indeed that was short or open, and corrective action will take place. So similarly, pick and place machine, there are two types of machines. One is a chip shooter. Chip shooter is so fast. It goes, there's a nozzle, vacuum nozzle. It will go pick up a component and then place it onto the board at a predefined places. And there are some reference point, and it goes, and every time it goes, there's a reference, and that is how it's able to locate the exact location where it's to be placed. Then there's a placement machine, which is slightly lower and larger part that is there. And again, pick and place, it will pick up the component, it will go through a camera to make sure that all the leads are not bent and are there. The orientation of the component is correct. So at every stage, it's being seen and measured. Then it goes through a reflow oven. That is where the solder paste reflows and a joint is created. And then there's a post-soldering inspection station. So at every stage, there's a check and balance and a report that is generated. And we, as a part of the manufacturing engineer, have to make sure that any time any machine produces a report, that particular serial number is to be seen by the technician to make sure that the problem, if it is there, is addressed. This is, I would say, this is the most important part. You know, when you say a new product, how do you make sure that the product is both meeting all the specifications, but specification is not only important. Other thing as long-term reliability of the product is important. How it manages during the shipment, and how is to make sure that there is no RF radio wave frequency that it generates, because most of the product, if you see, they say it is not going to interfere with your television or with other signals. Um, Whenever a pilot takes off, they always says, please turn off your devices, because at that time, long time ago, there were chances that most of these devices would generate a frequency that would interfere with the navigation system of the pilot. And then reliability and burn-in. Let me go through some of these. Two-corner and four-corner test. You know, there are two variables in a board. Number one is temperature. Remember, as you power on any devices, the temperature keeps on going up. And then each devices, there is a voltage that goes in. The voltage could also vary. So this particular two-corner test is to make sure that at high temperature and at high voltage, so voltage is also plus minus 5%. So when we say 5 volts, it means it should be within plus minus 5 volts. So if it is plus 5% above 5 volts. And at high temperature, we test the product, and then at low temperature means I would say -5 degrees, and also low voltage. So that is known as the 2 corner. Then comes 4 corner, which you're testing for all the 4 extreme corners. That is, at high voltage, you have high current, high voltage and low voltage. And then you also have that low temperature, high voltage, low voltage. And each of them has 1 corner. See, high voltage, low voltage, high temperature, low temperature. So this accounts for 4 corner test. This is to make sure that the product is being qualified to meet the existing conditions under which the product would be operating. If you talk about space, by all means, there'll be another line that will be added on, which is going to be the most severe testing of the product, because you don't want product to fail once it goes into space. Shock and vibration. Why is that important? Because you might have seen some videos about how the boxes are just thrown out of the planes, how the delivery person, UPS or whatever delivery that you're using, they'll just drop it from 3 feet up and boom, it just bangs there. So we have to make sure during design stages that our packaging is properly qualified. We do both shock and vibration to both as a packaging and also at the assembly level, that is without packaging. And then once it's all qualified, the part of the product development cycle is we are going to ship a product in its complete packaging from the factory to location A. Then we ask location A to receive it, and without doing anything, ship it to location B. From B, it goes to location C, and from C location, it comes back to the factory. So it has taken at least 4 rounds of delivery, and that we believe should take into account anything that happens to the product. So the product, once it comes back to the factory, we open it and we go ahead and test the product for every specification, and it must perform the way that it was initially sent out. And once we are able to do this on 10 different products at 10 different times, the level of confidence really increases, saying that, yes, we have designed our packaging to meet all the shock and vibration the product will take up during shipment or during the usage of the product. For example, the product could go in the car and car is vibrating and jumping, and it might go across speed bumps and potholes, but the product must not fail, or the solder joint must not break at any one of these points, because if it breaks, the product is going to fail. RF testing, there's a whole separate room. I mean, such a complex room I went into, and all the products are tested to make sure that it does not develop the frequency which is going to interfere with your radio frequency. And that is done, all is done during design stages. Reliability. What is MTBF? As a manufacturer, you want to have a confidence in your product that mean time between failures. How do you establish mean time between failures? Is that there'll be 100 product that has been built will go through the testing, and these all testing is as per the customer environment, at high temperature and low temperature and everything. And anytime there's a failure, it will be recorded. And when they say MTBF, mean time between failure, is 10,000 hours, that is how you're able to come up with those numbers because you have actually taken the product through 10,000 hours of testing to make sure that the product is reliable. And that is a confidence. That's the number that we give to our customers. And this reliability test goes on from day one to the end of the life of the product because those bays in which the reliability goes on are continuous. So that is where more and more customers develop that confidence that mean time between failures are coming down. And if you can have zero, right, mean time between failures is not zero, I'm sorry, is very high. 10,000 hours or 20,000 hours. That means the product is more reliable. Burn in. Burn in is every product goes through a high temperature testing because it is at a higher temperature, a product is more liable to fail. And all of this is a part of design and development cycle. Once we go into production, many of these will not be required because we know from our testing that after building the product, uh, I think I will go through that, proto build and pilot build and production. That our product will not see these type of problems. So these all happen during during testing of the product at new product stages. BOM. I was saying about those 5 things, right? So this is material or the BOM. This is the list of all part, material, and assembly needed to make a new product. Now, each one of these components has been qualified by design engineers. And once they release an EC, which is engineering change, saying that this particular part number is qualified, manufacturing cannot change that. So this is to make sure that we are very consistent in doing our roles and responsibilities. Every part will have its part number, revision, the quantity that is used onto the board, the reference designator, the location at which it would be mounted, the cost of the product, who the manufacturer is, the manufacturer's part number. Now, all of these are very important. What is the cost and what is the specification on that? And all of them form a part of the spreadsheet. And when someone looks at this material, he will be able to understand what it takes to build a product because it also has all the processes and sub-assembly and testers that are required. Testers, quantity used will be 0, but it will be specified that this is a tester that is required. Again, all the sub-assembly and assembly, these are the direct cost. Most of the product cost that is sent by manufacturing are the direct cost. And then on top of it, there are many indirect costs. For example, marketing cost. Marketing is about 30% of the cost of the product goes into marketing. If you see all the advertisement on the TV and the cards are putting up so big ads every day, those are the cost of marketing a product. And then there is design engineers, their cost has to be added. On top of that, we have to add how much profit we are going to make. On top of that, we also have to add what cost it takes to rework a product. And in case there is a recall for something, that also needs to be accounted for. So all of this is added to the direct cost. And then they come up with the product cost. And on top of that, 30-40% profit. When I used to work for Cisco, it was expected that every product should have 70% margin built into this. This is after taking into account everything. So that was the margin that they wanted to have for their products. how small are these products or how large are these? This you can see, if you look up at the BGA, for example, the lower right corner, all all the BGA's ball gate array. So these are all the balls that are mounted on these devices. And from the top, you cannot see them. And that is why X-ray has to be done to make sure that there is a connection of every signal to the pad on onto the board. So ball is a connection inside the device, and outside are these. We have to make sure that the board makes the proper contact with this electronic device. Again, you have QFTs. Now, these are very, very fine pitch components. You have CLCCs. Now, in these, the leads bend and they go underneath. So again, the connection is really made underneath the component. Then you have SOICs. I don't see there. Yeah, there it is, SOICs. And these are our PLCC, same thing as CLCCs. These are the components that are very, very fine pitch components. And how big is QFT, for example? A QFT could have, I have seen on my boards about 200 IOs. So if it is a square, you're going to have 50 signals on each side. BGA, how big is a BGA? BGA has about 800 IOs. So each one of these solder ball that is on the BGA is an IO, input, output. So again, we have to make sure that every solder joint is connected properly. That is how the product is going to pass all the tests. If any of this has a problem, it will be caught in one of the different tests that is set up in our manufacturing. You will see how small are the components. On the top, 2010, which is about 0.2 inches by 0.1 inch, those are old technology. The same thing now comes into the size of 0.01 inch. Imagine how small it is. It's so tiny that anyone who wears the glasses, and if your glasses is a little bit off, he will not be able to see that component onto the board. They are very tiny. And remember, each one of them has to be picked up by a nozzle. Now, when we talk about pick and place machine, there's a nozzle that goes in, which has a vacuum. It goes on the component, it sucks the component onto the nozzle, then it goes to the location and places that onto the. That is where this technology is going. And the board is becoming more and more complicated. Just like in big cities, land is not available. Similarly, onto the board, the land onto the board is very expensive because it has a limited size, and we want to have as much component mounted on that board. Component are mounted either on the top side or the bottom side of the board. Here is one example I'm just showing you. On the left side is an image of all the traces that go from point A to point B. And these are on multi-layers. And how are the layers formed? It's just like high-story building. So nowadays they have 24 different layers because the board is so complicated. It has to go to every component, and only way it can do is some of the signals go from inside core. So you have inside layer. Here we have just 1, 2, 3, 4, 5, 6 layer board. This is 6-layer board. And the hole that you see from top to bottom is known as the via. That is the one that is making connection. You have via on top, bottom, and in between also. So each one of them is a different layer. Remember, these are all different layers and they are mounted on top of each other to form a printed circuit board. And when you have components mounted onto the board, it is known as printed circuit board assembly. So you can see how complicated the board is. Method. What are the different methods? Remember, we talked about a product has to be very reliable. It is all done from this process. Proto build are for the design engineers. They want to make sure that because it is all the components have not been put together to verify it. When it's all put together, it goes to our design engineers. We do our inspection. We can only do optical inspection, visual inspection, because we do not know the functionality of the board at this particular point. So design engineer says, you do your inspection, make sure that it is being built as per our specifications. Then they go ahead and test the product. If they find that there's a problem with the board, they will go ahead and respin that and do the pilot build again. Pilot build is to make sure that we are processing towards repeatability of the product. And when design engineers are satisfied that their design is okay, believe me, their proto build happens, proto build 1, proto build 2, proto build 3. Sometimes it used to go as proto build 6. Every time there's a proto build, remember, it's a loss of both time and revenue. And when we give our input, DFT, DFM, and design for assembly, DFA, that is where most of the proto build that is happening, we are able to reduce proto build from proto build 1 or maximum proto build 2, because our input really improves the design. Pilot build is the one at which we say, okay, the product has been released by design engineers. There is specifications for every component. Every component has been qualified. And so we build only from the BOM that is qualified. Whole process is put in place. All the machines are working. For example, ICT is qualified. Your functional tests are qualified, everything. And then you run anywhere between 100 to 250 as a part of this particular build to check for repeatability of the product. And every product that is being built, we analyze for the failure. And every failure, if during this analysis, we come to know that it is design-related failure, that is when it goes back to proto build again, because still there is an issue. This issue could be also component that is there. Or when we talk about design, we talk about clock rate. Some of the clocks do not match, and one of them may not perform as per the clock rate of others. And this is what leads to something known as design-related failures. And once the pilot build, we are satisfied that, yes, it does not have any design-related issues. Whatever issues are there, we go ahead and identify as either as a component-related issue or a test-related issue, or it could be operator-related issue, or it could be no trouble found. So all of that needs to be analyzed. Every failure has to be analyzed before there's a flag that is given, okay, we are ready for production. Between the proto and the pilot, that is when a good sample is really given to our customers for their own qualification. Remember one thing, a customer will have to qualify your product once again to make sure that it's able to meet their specifications. Normally, our specifications are more tighter than the specification given by the customer, because that is how we'll be able to make more reliable product. But every product will require requalification by our customers. And at that stage, at the pilot stage, they are ready to take the shipment of the product. Their purchase order is ready, and everything. The money is just coming in, and we go into production. Production is when we are able to scale and become profitable. How do we scale? Because not only we can, if we have one manufacturing line at the location, we can set up 2 lines or 3 lines or 4 lines. So all of a sudden we'll have 4 times the product. As long as there is a space that is available in that building, that space will be used up by setting up all the production lines. In case we require more space, then obviously the product will move to some other location. And again, the whole qualification process will start all over again. Not only design engineers are going to check that product, even our customer, whenever there is a change in manufacturing site, it has to be informed to a customer. As a matter of fact, even every EC, engineering change, has to go to a customer. They know exactly what has changed because it's our responsibility to tell them. But whenever there's a production that is at a new site, it goes through a whole set of qualification again. But at that time, because everything is qualified, every component is qualified, every machine is qualified, every operator is trained, and the chances of it being qualified are very, very high. That is when we go into scalable. At that time, we had manufacturing not only in the United States, we were also running our manufacturing in Mexico, we were running our manufacturing in Penang, and we were running our manufacturing in Holland. Imagine, I'm not kidding, so in the daytime, we are busy with Mexico production. In the evening time, that is when Penang's time, 8 o'clock starts. And the nighttime, 2 o'clock, is when Hungary starts production. It is 24 hours duty. You have to make sure that you are able to address the issues. And if there's anything known as line down is when there are 3 failures in a row, an operator will shut down a line. He'll inform to the supervisor. Supervisor will shut down the line, and that is when everything comes to make sure to address that particular problem. Until unless there's a corrective action put into place, the line will not start on operating. And that's the quality that we need to put into a product, because nothing should go out of the door with a known problem. That is just no. If it goes out, you're just destroying the company. None of the company in the Bay Area will sacrifice quality for their customers. And that is how these companies are able to sustain and establish themselves as world leaders in multiple countries. All the processes now, we have talked about material, we have talked about machine, but training, every operator is trained as a part of ISO 9000. Remember, 9000 is whatever you say, you do it and you document it. If we document that our operators are trained, then where is that training manual? A high part of our resources go to train our operators to make sure that they understand the process and what they're supposed to do. Data collection. Most of the machines, again, are already, they have collected the data because they know the product that goes through each machine, they know whether it has passed or failed and has a date stamp on every failure. So we come to know which machine and at what time there was a failure that was seen. Serial number is, again, for all uh, traceability. Remember, many times you might have heard a recall from the factory. How does factory come to know which customer has which product? That is where traceability is so important. Every small component that is used on the board is well documented and traceable. When they put the product on tape and reel, that is for, am I going too technical? I'm not sure. So tape and reel is where the pick and pick place machine will pick up the product. So that has its own revision and manufacturer's date code. And you scan that and you tie that particular date code for that particular component to this device and for the complete assembly. So that is traceability and very important. Failure analysis, I don't have to emphasize on this because nothing should really fail. And if it fails, there must be a root cause analysis that was done. I talked about line stop and stop shift, because when there's a line stop means there won't be any product that will be shipped. As a matter of fact, even the product that has been ready to be packed and shipped will be brought back for rescreening because there was a line stop and you have to make sure that problem was not there. Cost reduction is, again, very important. Now all of these engineers are required for each one of these tasks that I'm talking about. This is very important as far as manufacturing is concerned. The last part is cost reduction. How do we reduce the cost? Now that happens. Number one is some of the tests that are very long, and we have, through our data collection, we have found out that such a long test is not required. Then you go ahead and shorten that test there. And again, as I told you, shop hours. If the shop hour decreases, the cost is going to decrease. Number two, whenever you do failure analysis, that means you are able to identify the root cause of the problem. It is expected that once you identify the root cause, we should not see that problem again. That will lead into better yields or less. If there's a less failures, obviously you're going to have cost reduction. Number three, whenever you work on the product, you gain knowledge by manufacturing it, and you are able to come up with the process that is faster, better, and smarter. That is how you're able to reduce the cost. Number four, each one of the component that we buy from our suppliers is renegotiated because now you're going to much larger production. And as the production goes up, the cost of the component also decreases. So that is another part of the cost reduction. Number five is many of these boards have components that were mounted only for our test purposes. So there might be a lot more test points, for example, that are there that were required for design engineers to their own troubleshooting. But once we go into production, then it's not required. That is where some of these components, some of these pin and points are taken out. Remember, anytime anything comes off is a cost reduction. You might say, okay, Suresh, you're just saving 15 seconds or 20 seconds. Absolutely. But remember, if you're building 100,000 of those 15 seconds matters and it adds. Number seven, many of these customers says, I do not need this feature because we have built with that feature for many, many different companies. And some of the companies says, I don't want that feature, can you take it off? Sure, we'll take off that. So that is where cost reduction boards are made because that will not have that particular feature going to a customer who does not need it. Number eight, many times we go ahead and we merge many of these ICs into one single IC. So that is where a big cost saving comes in. But remember, cost saving here, but there's a lot of design and development that goes on in order for that particular new device to be fully operated. For example, a microprocessor, right? There's so many things that's happening in the microprocessor, but it cannot happen every day, every time. So that itself is a big process. But once that happens, all of a sudden you reduce the cost by $2 or $3 per board. And when you're building 100,000, you're talking about close to $1 million saving. So when you do all of that, you will find at the end of the year, you have done close to about 15 to 20% cost saving from the earlier price that was set by manufacturer. This itself is plan, do, check, and act, and I'm sure you're teaching to your students, and that is what is done as a part of a process improvement. That every time there's a failure, it will go through this cycle. You know, we plan and we do and we check and act, and corrective action takes place. And again, a second set of corrective action takes place. Still, any failure will reduce to a noise level, but even that noise level, we analyze the noise might be once a month, but once it is once a month means 12 times in a year, we see that. Then we also go ahead and start working on that to reduce that noise also. And this all happens through the right side that you see. All these loops are there to make sure that we are able to work on a product that becomes more reliable, less failures. My friends, every failure is an opportunity. Remember, every gap is an opportunity for entrepreneur. By this, what I mean is, if our testers, for example, is unable to catch a problem, that becomes an opportunity for someone who says, I have the right knowledge, I have the right experience and right expertise to design a separate tester that is going to catch all the problems. So that is where every person in the Silicon Valley is an entrepreneur. Well, I think I've covered up some in little details, but I hope you are able to understand the process, what it takes for a new product to be developed into production in the Silicon Valley. Many of these you can take it forward and will be directly applicable everywhere, because no matter what the product is, any failure has to go back and root cause of the failure must be identified. That's the only way you can reduce problem, no matter if it is electronic board or car manufacturing or any production that is there. That's the way to get rid of. I will I will leave it for some of the questions that you might have. Yeah. Sorry, I have to hurry up on certain of this, but I wanted to make sure that you understand where your engineers will be required. Because next time when you take a class, you can teach them that, look here, you are all going to be engineers, and this is an opportunity where you will have your expertise and experience. And once you gain that, you might be ready for an entrepreneurship that we are talking about.
Professor Roy, thank you so much for for your experience and the way you explained. I think it was wonderful, very clear. I would say one thing which kind of becomes very obvious. When we talk about the total available market and total and the serviceable market, and then we come to target market, and then we come to your selected target market. All it is saying is you have to kind of do locally. That means you have to find your customer locally. That's you find your customer locally, then you'll be able to make a product, and you'll easily go to and go to the customer and get it tested. That feedback will be so fast, because and then you have to go. What does scalability means? Reliability, repeatability, scalability. That means you have designed through all this DFM and DFT and DFA and DFR. You have done all of that using that. So, and now you can produce. Now you can produce thousands and thousands and thousands of units every day, only if you have gone through this. So Professor Roy actually took us through that, and so for our startup, for when we as an entrepreneur, I think we need, our first objective is to go and look at the local market, close by local market. That's what and when we succeed in the local market, then we go ahead and expand, and that's what all the bigger companies do actually. And Professor Roy took us to that. Uh, think about, this. He talked about four corner testing and shock absorber. This is shock and vibration testing he talked about. Just imagine Chandrayaan goes up, what vibration it goes through, what temperature variation it goes through, what what heat, and what the voltage and how it is done. Can you imagine? Now you can start feeling the appreciation of the work which these companies are doing, which our ISRO is doing. That, my God, what a, all these things they have looked at very, very carefully, and it is and when you go into one of the things Professor Roy mentioned about zero defect, that means they want to do that there's a zero defect in the product so that it doesn't fail. And that's the way the process is, so that and because in all these when we have this Chandrayaan, then we cannot afford any defect. And you saw, if you miss one thing, saw what happens. But anyway, that's it. Thank you so much, Professor Roy. Now, please, if you have a question, you can raise your hand, or you can just unmute yourself and ask a question. Just or you can say, write it on the chat box. So go ahead, please. We'll have about 10 minutes we'll spend on the question, because it's already too late for you. But before I go to the question, I would request you. There are altogether we have 23 faculty members, and I have got the input from 14. So I need to get input from 9 more. So if you have not done it, please go ahead and say the question which was asked, that are you willing to teach entrepreneurship starting in 26, 27? Answer yes or no. So those who have not responded, please go ahead and do it. And no is a good answer too, because that means that's your choice. That's okay. So please go ahead and complete that. I would really appreciate if all of you can do that. Okay.
So, Professor, I just wanted to point out that no matter it is a startup company or an established company, the most important is talking to your customer. And a very well-established company goes to the customer almost on a monthly basis, and they have a meeting, and that is where they talk about potentially new product being developed, or the issues that they are seeing which needs to be addressed. So contact with the customer is very important.
Good. Okay. Yeah. And so while we're waiting for the question, I want to say one other thing. All of you who have said yes, I want to make sure that you have access to all the videos and you have access to all the PDF. And if you do not, please post it on our common WhatsApp group, and I will make sure that all of you have it, get it right away. Okay. So I'll just say, uh, I really want to thank those faculty members who have said yes: Mukesh Paul, Sunny Kumar, then Manorama Bassett, Dr. Devashish Shah, Professor Rekha, and then Professor Bimal Sao. Thank you so much. Professor, of course, uh, Professor Kumar Naveen. Thank you. Professor Neeraj Sharma, Professor Hina, and then we have Professor Mrinal Srivastava, Professor Divya Shikha, Professor Dushyant Roy, Professor Ritika, Professor Anjani Mandal, Professor Anupma Singh. These are the one who have said yes, and I just see one more, Professor Amarnath, also Amarnath. Oh yes, Professor Amarnath Sinha. Thank you. Thank you so much, Professor Amarnath Sinha. Okay, very good. Okay. So I have shared with you I have shared with you the template for the presentation. So please go ahead and share that with your student, and so that they can start feeling how to do it, and we will have the next week. Next week we are going to have a review for the final exam, because final exam is coming. I understand that it has been announced and it is on starting January 28th. So I want to make sure that we have the review, and whatever we have covered in the class, that's what will come. And then, but however, we will keep on continuing the class. We'll keep on continuing the class because I'm sure all of you would have a lot of questions. So we'll keep on continuing class even after the exams, till the whole the course is fully covered. Okay, so that's all I have to say. Professor Roy, you want to add something?
Well, not hearing anything from the professors makes me believe or unbelieve in myself. Whatever I've said, did it make sense or no
I,
sense?
no. For this class, I would say that there's so much information, and they are going to, when they look at your PDF, then they will they will start looking at. I bet they will keep that PDF as a reference book, because it will have a lot of data, a lot of information, and they will all. One thing I know, whoever has attended this class, they all are going to become entrepreneur. That something tells me that, because entrepreneurship is all about passion, and this is attending all these class and remaining focused. I think it is a lot of passion. So I really believe that all of you within I will even give within a decade, I will say all of you would be entrepreneur of one kind or the other. That I can tell you. I can feel that. Okay. Uh, so
Can
with
I add
that,
one more thing?
uh,
Just one more thing, please.
sure.
I just want to tell everyone, how are the manpower in United States? When I was working for Solarlatics, it was a startup company, small company with 21 employees. And will you believe if I tell you that 21 employees were from 11 different countries?
Oh,
11 different countries working together on a project.
yeah. And another thing,
That is
yeah. Go
that is
ahead.
what is Silicon Valley.
Yeah, yeah. And another thing, no matter what your position is here, no matter what position is, whether you're the president of the company, whether you are we are a low, you are lower. If the work is there, no matter how, whether it's a whether it's your water is leaking in your toilet, or there is something else, customer visit, no matter what the work is, everybody does that work without hesitance, without any feeling. ये नहीं कि वो ये तो हमारा काम नहीं है, ये तो दूसरे का काम है. In entrepreneurship, that doesn't happen. Just whoever reaches first, and if that person has the capability, has the domain, he just goes and works and fixes the problem. So हम लोग को entrepreneur बनना है ना. तो और ये जो पढ़ाना भी है, क्लास में पढ़ाएंगे भी, right? यही हमको करना है कि no matter what happens, we take a commitment, and we really, अंदर ये, you yourself are already an entrepreneur because you are committed to teach this class. पहली बार हो रहा है झारखंड में, झारखंड यूनिवर्सिटी में पहली बार हो रहा है, and you are being part of it. So congratulations, and I'm so glad that we are involved, and we are working with you. Okay, very good then. Thank you so much, and I'm going to close the meeting today. I think it was. I'm very happy because the class was all
Thank you, sir.
the each one of the members stayed. Yes, Sunny, you were saying something. Sunny.
I was saying thank you, sir. Thank you for the session.
All right. Thank you, Sunny. Thank you. All right. Thank you. Good night from California, and
Thank you, sir. Good night, sir.
thank you,
Thank you, sir.
thank you so much.
Thank you, sir.
Thank you, sir. Good night.
Thank you. Good night. Good night and good
Thank you,
morning.
sir.
And you have a very good day. All of you have a wonderful day. Professor Roy?
Yes.
Yeah, you're departing. This is your last words. You always have wonderful things to say.
When we think about this, and think about zero defect, that is a lot of responsibility that comes in, because it takes effort by everyone in order to achieve that zero defect. It starts from the president of the company, from design engineers, all the way to the operator, to make sure that everyone is focused on zero defects. That is where all the training and all the documentation really comes into play. So no matter what you do in your institute, try to make sure that you're able to address all the issues that is within your control. And I'm sure if you look around, there are a lot of things that you can improve right in your institute. Today, set up your mind that you're going to work as an entrepreneur. You're going to resolve many of these problems that you see around you. And then you will see how the students will start trusting in you, and your respect will go up multifolds when you try to resolve their problems.
Thank you so much. Thank you so much with those golden words. Good night.